This question belongs to the subject Digital Logic Design and was asked in GATE 1991. And the topic name is Sequential Circuits. So the question states, choose the correct alternatives, more than one may be correct, and write the corresponding letters only. Advantage of synchronous sequential circuits over asynchronous ones is faster operation, ease of avoiding problems due to hazards, lower hardware requirement, and better noise immunity. Or we have option E, none of the above. So here, what are synchronous circuits and what are asynchronous circuits? In synchronous circuits, we have the same clock pulse in every flip-flop. But in asynchronous circuits, the output of one flip-flop may serve as a clock for another flip-flop. Thus, in synchronous circuits, all the output will change at the same time, and asynchronous circuits are unpredictable. So for this, refer to these statements. So what option A states? It is asking synchronous sequential circuits over asynchronous one. What are the advantage? Faster operation. So C says this. In asynchronous circuits, there is no clock, and the state of circuit changes as soon as the input changes. Since they do not have to wait for clock pulse, as there is no clock, we do not have to wait for the clock to begin processing inputs. Asynchronous circuits can be faster than synchronous circuits, and their speed is theoretically limited by the propagation delay of the logic gates. The flip-flops are made of logic gates, thus, due to the absence of clock, they can begin processing the input as soon as they want to with the delay of the clocks only. Thus, this option is false. Synchronous do not have faster operation, asynchronous have faster operation. Let us see option B. So option B is saying ease of avoiding problems due to hazards. But option B is true. Like synchronous circuits can easily avoid the hazards because if transition on two inputs arrive at the same time, in synchronous circuits, the circuits can go in wrong state depending on slight differences in the propagation delay of the gates. This is called race condition or hazard situation. In synchronous circuits, this problem is less severe because race condition can only occur due to inputs from outside the synchronous system. Thus, synchronous circuits have less severe hazard problem. And you can refer to this link for this given statement. This statement has been taken from this Wikipedia link. So option B is true. We can easily avoid hazards in the synchronous circuits. Option C. Option C is false because of this above statement only. Because if we don't consider how to avoid hazards in the asynchronous circuits. Thus option C is true, false. Like lower hardware requirement is not there in the synchronous circuits. Option D, better noise immunity. So you can refer to this paper. This paper is regarding the behavioral transformation to increase noise immunity in asynchronous specifications. So option D is false as better noise immunity is not an advantage of synchronous sequential circuits. You can see this statement. This statement is taken from the paper. So this statement says asynchronous circuits seem to have good candidate to alleviate the problems originated by simultaneous switching noise, which means asynchronous circuits are used to avoid this noise problem, which means synchronous have this noise immunity problem. However, they are also more sensitive than synchronous ones to spurious signal transition and delay variation produced by crosstalk noise. You just refer to this statement. It's a good candidate to alleviate the problems originated by simultaneous switching noise. Thus, synchronous do not have better noise immunity. And option E is also false, none of the above. So answer is option B.